So now let's really start work. So we're going to work on the item A first. In other words, we are looking for electric field at x equals 1 centimeter. To be more precise, let's define x equals 1, this particular point, it's called point A. So in other words, the point A is directly situated at x equals 1 centimeter, so which is over here. So this is my point A. Okay, so that's my point A. Because this is the 1 centimeter, it must be set over here. So then let's look at the distance between these two. In other words, we're looking for R1A, R2A, R3A, R4A. So we're just looking for these distances. And so once we found the distances, then we can just plug in the equation, do the calculation. Let's calculate distance. Let's do one at a time. We're looking for R1A first. R1A, it just equals the distance, the coordinate of field point, which is 1 centimeter, minus where the source charge locates. For the Q1, it locates 1 centimeter. So therefore, the distance between field point and the source charge for the first point is just 0. There is no distance because this time field point and the source charge point are exactly the same location. But what about 2A? Well, 2A is also simple. Did you see the x2 is 0.05? So the distance between the Q2 and field point here will be 5 minus 4. So you will get 0.04 meters. And you can do the rest of them easily because, for instance, the distance between Q3 and field point A is just 7 centimeter or 0.07 meter. So that's what you get. Sorry, my space is a little bit narrow now. The last one is also simple because that's 14 centimeter, 1 centimeter. So this is 0.11 meters. So that is what we got. I just want to give you a caution. For this particular part, it happens that the field point is directly at first charge. It just happens to be at the first charge. So therefore, it somehow appears that you calculate distance between Q1 and Q2, Q1, Q3, Q1, and Q4. Because the field point that you are interested in is at point A. So there's nothing else. So that's just want to make sure we are looking for the distance between the field point and the source charge. Do not get confused just for this particular part because it happens to be that these two are exactly the same location. And that is very, very crucial. Once we found the distance, we can find the electric field directly. So now to be more precise. And let's first calculate contribution, the electric field from Q1 to the point A. So what I do the following. First, I use a little 1, which is representing which charge you are looking for, which we're talking about. Charge Q1, so I just put a 1 here. And then a comma, Second point, what I want to write is a field point, which is which location you are interested in finding the electric field. So that is what we write, and the electric field is a vector. So I can take absolute value of this because that just gave me the magnitude. So just write this down, and this we already learned from last class. Again, take absolute value, Q1, absolute value. Bottom here, we have 1A square. Put a comma over here. So then we just plug in these numbers. 8.99. That's Coulomb constant. We know the Q1, which is 2 times 4.2 times 10 to the negative 9 coulombs. So that's what we get here. Because I take absolute value, so the negative sign is gone. The denominator is the distance, as I mentioned many times, which in this case is 0 squared. So therefore, you know that if you do the calculation, and you have found this is just infinite. For this reason, that's why normally we do not want to calculate the electric field at the charge located, where exactly located, because this it gave you infinite, and physically it never happens like this. Just mathematically it could behave like this. Okay, now once this term goes infinite, you do not need to do the calculation for the rest of these terms, because when you add them up, it all give you 0, or all give you the infinite. Anything you add infinite, just get infinite. So your final results is just this infinite. So that's what we get. Now, it may appear to be that online homework could have a negative sign, and some of you need to tell me, check this one here. So this is the first part, A, relatively straightforward. Again, there's no need to calculate for the Q2, Q3, Q4, because it doesn't matter how large these values electric field from these charges, and so they all adds up to infinite. So this is already done. Now we're going to move on to part B. Part B, let's look at the part B. Read it again. It says the following: find X component of the total electric field in newtons per coulombs at X equals 11 centimeter. This time, you are not lucky like you give infinite. No, it's 11 centimeters. So this is the 11 centimeter probably over here. Let's just put B here. So what we're looking for electric field at point B. And this is a vector. Electric field is a vector. If you have many charges, so therefore the contribution, you have many more contribution to do that. And this is the most rigorously written in the following way. If you write them down, and you will find that this B has a contribution from the charge number 1. So we just write down 1B. Charge number 2. 2 comma B. Charge number 3. Charge number 4. So now you have 4 terms total. And this makes things really, really exciting and also interesting. And what is even more problematic or more urgent is that we need to figure it out, because did you see we have these vectors. Vectors need directions. So we need to simplify it, which we call the simplification of E by finding the directions of E1B, 2B, 3B, 4B. So we need to find the direction of the electric field at point B. And this will be the next video I am going to show you.